let's say that f of x is equal to x squared plus x minus 6 over x minus 2. And we're curious about what the limit of f of x as x approaches 2 is equal to. Now, the first attempt that you might want to do right when you see something like this is to see what happens. What is f of 2? Now, this won't always be the limit, even if it's defined, but it's a good place to start just to see if something reasonable could pop out. So looking at it this way, if we just evaluate f of 2, on our numerator, we're going to get 2 squared plus 2 minus 6. So that's going to be 4 plus 2, which is 6, minus 6. You're going to get 0 in the numerator, and you're going to get 0 in the denominator. So we don't have, the function is not defined, so not defined at x is equal to 2. F not defined. So there's no simple thing there. Even if this did evaluate, if it was a continuous function, then actually the limit would be whatever the function is. But that doesn't necessarily mean the case. But we see very clearly that the function is not defined here. So let's see if we can simplify this, and we'll also try to graph it in some way. So one thing that might have jumped out at your head is you might want to factor this expression on top. So if we want to rewrite this, we could rewrite the top expression, and this just goes back to your Algebra 1, two numbers whose product is -6, whose sum is +3. Well, that could be +3 and -2. So this could be x plus 3 times x minus 2, all of that over x minus 2. So as long as x does not equal 2, these two things will cancel out. So we could say this is equal to x plus 3 for all x's except for x is equal to 2, as long as x does not equal 2. So that's another way of looking at it. Another way we could rewrite our f of x, I'll do it in blue just to change the colors. We could rewrite f of x. This is the exact same function. F of x is equal to x plus 3 when x does not equal 2. And we could even say it's undefined. It's undefined when x is equal to 2. So given this definition, it becomes much clearer to us of how we can actually graph f of x. So let's try to do it. So that is not anywhere near being a straight line. That is much better. So let's call this the y-axis. I'll call it y equals f of x. And then let's, over here, let me make a horizontal line. That is my x-axis. So defined this way, f of x is equal to x plus 3. So if this is 1, 2, 3, we have a y-intercept at 3, and then the slope is 1. The slope is 1. But it's defined, and it's defined for all x's except for x is equal to 2. So this is x is equal to 1, x is equal to 2. So when x is equal to 2, it is undefined. So let me make sure I can. So it's undefined right over there. It's undefined right over there. So this is what f of x looks like. Now, given this, let's try to answer our question. What is the limit of f of x as x approaches 2? Well, we can look at this graphically. As x approaches 2 from lower values than 2, so this right over here is x is equal to 2. If we get to maybe, let's say this is 1.7, we see that our f of x is right over there. If we get to 1.9, our f of x is right over there. So it seems to be approaching this value right over there. Similarly, as we approach 2 from values greater than it, if we're at, like, I don't know, this could be like 2.5. 2.5, our f of x is right over there. If we get even closer to 2, our f of x is right over there. And once again, we look like we are approaching this value. Or another way of thinking about it, if we ride this line from the positive direction, we seem to be approaching this value for f of x. If we ride this line from the negative direction, from values less than 2, we seem to be approaching this value right over here. And this is essentially the value of x plus 3 at x, if we set x is equal to 2. So this is essentially going to be, this value right over here is equal to 5. If we just look at it visually, if we just graphed a line, with slope 1 with a y-intercept of 3, this value right over here is 5. Now, we can also try to do this numerically. So let's try to do that. So if this is our function definition, completely identical to our original definition, completely identical to our original definition. Then we just try values as x gets closer and closer to 2. So let's try values less than 2. So 1.9999, this is almost obvious, 1.99999 plus 3, well, that gets you pretty darn close to 5. If I put even more 9s here, got even closer to 2, we'd get even closer to 5 here. If we approach 2 from the positive direction, and then once again, we're getting closer and closer to 5 from the positive direction. If we were even closer to 2, we'd be even closer to 5. So whether we look at it numerically or we look at it graphically, it looks pretty clear that the limit here is going to be equal to 5.